another type of problem on PDF and CDF. That is, if x is equal to 4 cos of pi into capital N divided by 3, where n is the random variable whose value is equally likely to be any integer in the range of -1 to 3. So n is in between -1 to 3. So plot PDF, CDF, PDF of x and use it to find the probability when x is less than or equal to 2 it is. So in between 2 and 3, and when it is less than 2 and even greater than 2. So let's solve this problem. So it is a discrete time function. So as it is a discrete random variable, our x is discrete random variable. Now for this, n is a random variable whose value is any integer in the range of n minus 1 to 3. The first job is we have to find the value of x for the values of n from -1 to 3, and we have to take this n as integer, means -1, 0, 1, 2 and 3. So when we substitute n as -1 here, so it is 4 into cos of minus pi, 3 pi divided by 3, this n is -1. When this n is -1, we get cos of, so that is cos of minus pi by 3. So pi is 180 divided by 3. So it is as good as, it is cos of 60 degrees. So cos of 60 is 1 by 2, and even sine of 60 is 1 by 2. Cos of 60 is 1 by 2. Cos sine of 30 is 1 by 2. So cos of this 60 is 1 by 2 into 4, which is 2. So similarly, when n is equal to 0, we get cos of 0. So cos of 0 is 1, so we get 4 as it is, because this factor is making it as 1. Similarly, when it is 1, we get cos of pi by 3. So it is 2. When, and cos is a even function, so there is no effect. So even though cos of minus pi by 3 is, so we get the positive value as output. So when this n is equal to 2, that time it is 2 into pi, 2 pi by 3. So it is 360 divided by 3. So which is 120. Cos of 120 would be negative. Cosine becomes negative in the second quadrant. So we get, so cos of 120 is nothing but again 1 by 2, but with a minus sign we'll get -2. And when n is equal to 3, we get 3 into 180 divided by 3, which is nothing but cos of 180 degrees. Cos of 180 is -1. So -1 into 4 is -4. I hope these values are clear. Then once we are found with these values, the next thing is we need to go for finding the PDF. So P of x of -4. So we have 5 options. So x of -4 means getting the value of P of -4. So at -4 we are having, means for these values, so P of x of -4 is 1 by 5. Likewise for all these, P of x of -2 is 1 by 5. P of x of +2 is also, now P of x of 2. Now 2 is 2 times, so it will be 2 by 5, and for 4 it is 1 by 5. Then the CDF of this, even one can plot this, how this PDF function would be there. So we can take up a horizontal axis, and one can go for drawing this. So in this way, for different values, for x is equal to, this x is 0 will be here. So -4, -2 to 4. and the values are, it is 1 by 5, 1 by 5, 2 by 5, 1 by 5. So 1 by 5, let's take this much, 1 by 5. 2 by 5 has to be double than this, so it is 2 divided by 5, and last one is 1 by 5 again. These all are 1 by 5. So this is our PDF, which is represented by small effects of which is small effects of x. So let's see the next point. Here the CDF is to be found. So as it is asked, like, find when the PDF when x is less than CDF and PDF. So one can plot CDF and PDF. So this is our CDF. So it is at -4. At -4 it is 1 by 5. Again at -2, one more -5 adds, so it becomes 2 by 5. Again at 2, again 2 by 5 will be added in this way. And PDF is in this way as we saw. Then let's find what is the CDF. Fx of -4. Fx of -4 is equal to P of x less than or equal to 4. So it is found like when x is less than -4, P of x less than -4 plus P of x equal to -4. So this is equal to, when we are there on the right side of this, when we are there on the right side of this, we are not having any value. So as we are not having any value when it is less than -4, so it has to be a 0, and when it is equal to -4, it is having 1 by 5, so it is 1 by 5. So in a similar fashion, at -2 means -2's value, that is 1 by 5, and at -4 there is 1 by 5, altogether it is 2 by 5. So fx of 2 will be, what is the fx of 2? Fx of 2 is when P of x less than or equal to 2, means fx P of x is equal to -4, P of x is equal to -2, and P of x is equal to 2. These all get added, altogether it is 4 by 5. And similarly, fx of 4, it is the sum of all of them, so which will make it as 1. And to know this one, even PDF is asked. As PDF is asked, the PDF and CDF are related by the equation we know. CDF is equal to PDF is equal to differentiation of CDF. So from that, fx of x is equal to -4 is 1 divided by 5 del of x plus 4. So we can write in this way. Just by looking at this one, the amplitude is 1 by 5 and the position is -4, which makes it del of x plus 4 because it is on the left side. Similarly, x plus 2 for this. Its amplitude is 2 by 5, so del of x minus 2. So in this fashion, we'll write this. So to obtain this P of x less than 2 it is. So fx of x when is equal to P of x less than or equal to x, that is 2. So which is 2 by 5. Already those values are calculated. P of x less than or equal to 2, that is 2 by 5. Similarly, x less than 2 would be 2 by 5. When it is greater than 2, it would be 1 minus x less than 2. Means we have to substitute P of x less than 2's value, 2 by 5, which will give the other value. So So when x1 and x2 limits are there, it is 3 and 2, we get 0.8 minus 0.8 because fx of 3 is 0.8 and fx of 2 is 0.8. So we get 0. It is the intermediate point. Then the next thing is regarding the expectations to obtain E of the value. So let's see this problem. A random variable x, fx of x is equal to 5x squared, wherein x is in between 0 to 1 and it is 0 elsewhere. So find expectation, then E of 3x minus 2 and E of x squared, that is variance. Then to find this one, that is the second order moment, E of x squared. So E of x, or it is nothing but the mean value. So we know that E of x is given by integration from minus infinity to plus infinity x into fx of x dx. This is the formula and we have solved many of the problems on this. Let's solve this. Let's substitute the value of fx of x here. So this is x from the formula and fx of x is 5x square and dx. And as it is in between 0 to 1, so let's write 0 to 1 as the limits of integration. So the 0 to 1, 5x cube dx. When we do the integration, we get 5 by 4. I hope no confusions. Then E of 3x minus 2. To solve this one, so these kind of problems are solved by E of 3x minus 2. So E of 3x minus 2 is written as E of, let's say, some function that is g of x. And if it is E of g of x, then we write this one. This g of x is nothing but 3x minus 2. We write this one as g of x into fx of x gx. So this g of x is equal to 3x minus 2 into the value fx of x is equal to 5x square dx. And again by multiplying this 3x into 5, which will make it as 15 into x cube dx minus this 10x square. From 0 to 1 they both are integrated, so we get 5 by 12. And E of x square, the E of x square is integration from minus infinity to plus infinity x square fx of x dx. So which will be in this fashion 5 into x to the power 4 it goes to. So x5 by x to the power 5 divided by 5. So it gives 1. So these are the expectation problems. And even few more are being solved. Let's try these problems. And when suppose x is general discrete random variable with following probability distribution, then calculate expectation and variance of this. So for these, we know E of x is equal to, how to find. So from the previous knowledge, as we have learned this, so summation I is equal to 1 to n will be the formula x1 into p of x1 or xi p of xi. The summation from I is equal to 1 to whatever is the highest. So when we substitute, we get these values. So once this is known, then to find this variance v of x can be written. This variance is E of x square minus E of x. Here the variance can be written as, it is del also. It is E of x square minus mu square we used to write, and the value of mu is this itself. So E of x square we need to find in the similar fashion, wherein this becomes x square. So by using that formula, if we calculate, we are getting 10.55, and so this is 2.85. So when we subtract, we are getting 2.4275.